Hi, everyone. We're going to be reading section 2.1, a preview of calculus for our next week of class. And calculus is really one of the greatest intellectual achievements of all of humankind. But what is it, right? I mean, you've signed up for this class. It's possible you've even studied calculus before, maybe in high school. And do you know what it is, right? So if you look at Wikipedia, they say it's the study of change, right? And right now in our world, everything is changing, right? So studying change is really, really important. Wikipedia also notes that the word calculus, it's a Latin word meaning pebble, right? And they used to use them for calculations, which is why we have this abacus, cute little drawing of an abacus on our syllabus. So calculus gets a little deeper, right? It's not just like, oh, change, what does it even mean to study change, right? And so it asks several questions. So it asks things like, is your thing that's changing, is it increasing or is it decreasing? And so in calculus, we often, in math in general, we often look at these sort of generic functions like this, right? And so when we say, is it increasing or decreasing, we, in a graph like this, we read it from left to right and we just say, oh, is it going up? Right? Or is it going down? And so in this example here, this function is increasing, right? Approximately on, this is taking a moment to show up here, is increasing from about here out to out here, right? And then it's increasing again over here. And then it's decreasing when it's going down. Along this line approximately here. And then in calculus, we're going to dig a little deeper, right? So it's going up, but is it going up quickly, right? With all these coronavirus numbers, we're worried when it's going up fast, right? So for example, this one. So over here in this early part of the graph, right? It's increasing very quickly, quite fast. But if you look up here at the top of this little hill, it's still increasing. It's going up as you go from left to right, but it's increasing slowly. Okay, and so this, these little arrow lines that I've drawn in are sort of hinting at something called the tangent line, which we'll be studying, or we'll be at least looking at, if this is a preview, in section 2.1. And then section 2.1, oh, no, tangent lines, right? Before we move on, tangent lines, right, it looks like this boring kind of abstract idea, but actually it's really cool and it's used all the time. So for example, NASA scientists, right, sent the rover probe to Mars, right? 300 million miles away, okay? And the way they do it is they send it out, it has to like achieve escape velocity, it leaves the Earth, right? And when it does that, when it achieves escape velocity, it travels along a tangent line to the orbit that it was going in around the Earth when it leaves, right? And so the scientists had to calculate that tangent line with a great deal of precision so that 7 months later, 300 million miles later, it actually hits Mars, right? Tangent lines, they're important. Another thing that the book talks about in this section 2.1, again, a little bit of a preview, is area under a curve. And area may not sound like a very fancy thing to be studying, right? When you were a little kid, you learned how to compute the area of a square or a rectangle, and probably, hopefully, you still remember the area of a circle, right? But what happens when you have a squiggly blobbity blob, right? What's the area of that, right? And calculus gives us the tools to compute an area like that if you have a nice function that describes the perimeter, right? And so the amazing thing is that it's sort of the same idea that's giving us this area of a squiggly blob, as well as this idea of the tangent line. They're very closely related concepts, which is pretty cool. So that's what we're going to be studying about this semester. If we go back to our Wikipedia page, we see that calculus was developed independently at the same time by both Newton and Leibniz, which is kind of awesome and amazing that they both came up with this idea separately, but at the same time. Let's take a look at Newton here, this dashing representation of Newton. If we dig a little deeper on Wikipedia, we found out that in 1661, he went to Cambridge University. He had a work study role, so if you're in work study, maybe you can relate. He was at Cambridge, which is Cambridge University in London. But, you know, we have a Cambridge here nearby in Boston, and we dig a little deeper, and we found out that after Newton obtained his degree in 1665, the university closed down as a precaution against the Great Plague of London. In other words, Newton was a student whose life was extremely disrupted by an infectious disease. Given his privilege, he was able to hightail it out to his family farm, where he developed calculus. So while we all struggle with the very real tragedies of coronavirus, all of us mathematicians kind of have an eye out on you guys, you students, whose lives are being disrupted by this current plague, coronavirus, wondering which ones of you will take this opportunity to develop the next greatest intellectual achievement of humankind.